So in this question, we want to prepare a 575 milliliter, 203 micromolar solution of this aqueous magnesium fluoride. And the way you want to prepare the solution is we're going to take a concentration that's going to be even higher, and it's going to be this 549 micromole per liter. And this micromole per liter is the same thing as a micromolar right in here. And what we want to do is this is going to be our stock solution. And what a stock solution is it's a solution that's going to be in the back room of a chemistry department. And what that is, it's a very high concentration. And the reason why it's a high concentration is because you can just take some of the stock solution out, add some water to it, and you'll get a lower concentration that will be diluted of the stock solution. And that way you can have a lot more of this volume to do different experiments over and over again, versus taking this very high concentration and just using it just a few times. So you're able to stretch out basically how much solution you can get by using the stock solution that has a very high concentration. And so for this experiment, for what this chemist is wanting to do is he wanted to take out this 575 milliliters of 203 micromolar. And so what we need to do is we need to figure out how many moles this is that we need to get from this stock solution. So what I'm going to do is I'm going to draw a picture of this stock solution, and I'm going to draw a picture of the solution that we want to prepare. Now the solution that we want to prepare, I'm going to put right here in green. And so here's my solution I'm going to prepare, and I'm going to put down that this is going to be 203, and this is going to be the micromolar. Now to go from a micromolar to just a regular molar, you need to know that for every 1 micromolar, that's going to be equal to 1 times 10 to the negative 6 molarity, like this. And so what I can do is I can convert this right here from a micromolar to just a regular molar, and that's going to help me find the number of moles in a second. So if I convert this, this is going to be 2.03 times 10 to the negative 4. And this will be the molarity of the solution I want to make. Now I have the molarity, now I need to get the volume, and the volume is going to be this 575 milliliters, but I'm going to go ahead and convert that to liters. So this is going to be 0.575 liters. And what I need to do is I need to figure out how many moles of this magnesium fluoride that I need in this container in here. And the way I'm going to do that is I'm going to use this equation right here. I'm going to say that the concentration is M, that's for molarity, and that's going to be equal to the number of moles divided by the volume in liters. And that's why I convert this number right here to liters, because I need this right here to be in liters, and I also need this right here to be molarity to find the number of moles. And so you can see here that if I multiply the molarity times the volume, I'm going to get the number of moles. And so if I times this number here times this number right here, I'm going to end up getting 0.001166725, and that will be the number of moles that I have of this MgF2 right here. So what I need to do is I'm going to take my stock solution, which would be right here. We'll draw this pink beaker. And what I'm going to do is I'm going to put the solution like this in here. Now this is going to be the number of moles I'm going to take from here and put over here. And so I need to put down, this is going to be 549, and it's micromole per liter, or it's going to be a micromolar solution right here. Now I need to convert that to molarity. So that's going to be 5.49 times 10 to the negative 4 molarity. And what I need to do is I need to figure out what volume I need to take out of here to bring over here to get this number of moles right there. And so if I take more volume out of here, I'm going to be taking more moles, but I need to know the exact number of moles that needs to go from here over here in order to get this number of moles right there. So what I need to do is I'm going to use this equation right here again, and what I'm going to do is I'm going to say, okay, the number of moles that I want to get is going to have to be this moles right here that I have in this solution I want to prepare. So I'm going to have 0.000116725, and that'll be the moles, and that's going to be equal to the molarity times the volume. And the molarity has to be in this unit right here, and the volume will come out in liters. So I'm going to do 5.49 times 10 to the negative 4. That's the molarity times the volume here. And when I solve this equation right here for V, I'm going to get that the V, or the volume that I need to take out of this, is going to be equal to 0.213 liters. Now the question says we want this to be in milliliters. So what I'll do is I'll times this right here by 1,000, and I'm going to get 213 milliliters. So I can have 0.213 liters, or I can have 213 milliliters. So this is the solution that would have to come out of this in order to put into here to get this number of moles of the solution I want to make. So the answer would be 213 milliliters.